Okay, let's work on another example, something a little more interesting. We're going to look at a transfer function g of s equals 10 s plus 50. We're going to have a 0 at 50. And then we're going to have an s plus 2, pole at 2, minus 2, and s plus 200. Okay, so if we wanted to do the asymptotic Bode of this, the first thing we're going to do is we're going to look at the DC gain. We're going to ignore any free s's, and in this case we don't have any, so we're going to set the remainder of the s's equal to 0, and so what we end up with then is 10 times 50 divided by 2 times 200. Okay, and this is going to be equal to 500 over 400, and cross that out, and that equals 1.25. Okay, and so now that's a raw number, and so we need this DC gain in dB, and so we're going to say 20 log of 1.25, and that ends up at 1.94, okay, in dB. All right, so that's going to give us our starting point. Remember, again, we're going to plot that at omega equal 1, and so start labeling 10 to the 0, 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, and I'm going to start up here at 0 and 20 and minus 20. These are magnitudes, remember, and these are in dB, and this is minus 40, minus 60. Okay, that should be good. Okay, so at my 10 to the 0, which is 1, we're going to plot at 1.94, which should be right around there. Okay, and 1.94, let's try that again. Okay, just about 2. And so we're going to have a starting point. So we've got a point. Now we need a slope. We need a line in there. Remember, our slope is defined by how many free s's we have and where are they. Okay, if we have no free s's, then we're going to have a horizontal line in there. If we have a free s in the numerator, we're going to be sloping up at 20 dB per decade, and if we have a free free s in the denominator, we're going to be sloping down at minus 20 dB per decade. But in this case, we're just going to be going straight across, and so we're going across here. Now we're going to go across until we find find the smallest pole or 0. In this case, our smallest pole is going to be 2. And so we're going to move across here to 2, which is right here. Okay, and that's a pole. So if you remember our rules, each pole is going to take us down 20 dB per decade. Okay, each pole at the breakpoint. I'm sorry, that's a 0. Let's try that again. Minus 20 dB per decade at the pole. Okay, so each pole is going to take us down, and so we're going to go down 20 dB per decade. So if we look at this, we're going to go over 1 decade, and then we're going to come down 20 dB, and we're going to get a point there, and we're going to put a line through there, and that's going to be on our asymptotic line. Okay, and we're going to go until we hit the next largest pole or 0. The next largest pole or 0 is at 50. Okay, so we're going to travel down this line until we hit 50. And let's see, we're at 10 to the 1, so this would be 20, 30, 40, 50. So that should be right around in there. Okay, so we're going to do something there at the frequency of 50. Now, what we have here at 50 is a 0. And if we go back to our rules, what we find is that we have a slope change of 20 dB per decade at the 0. Okay, and remember, all these are slope changes, not absolute values, but slope changes. So let's go back here. And so we were heading down at 20 dB per decade. Okay, this is minus 20 dB per decade. And now we're going to add 20 dB per decade, so we're going to be going horizontal again. And so we're running across here horizontal, and we're going to go till we find the next largest pole, or 0, which in this case is at 200. So we're going to run across here to 200, which should be right about in here. Okay. No, right about here. Sorry. It's 100, 200. Let's do that again. Okay. So right about in here. And then we're going to see this is a pole. And so a pole tells us a change of minus 20 dB per decade. And so we're going to go minus 20 dB per decade again. So we're going to end up at over 1 decade, down 20 dB, and we should have a point there that we run a line through, and we should end up looking something like that. Okay, so this would be our magnitude, asymptotic magnitude plot for our Bode for this transfer function. Okay, so let's look at the phase now. And so remember, the phase is determined by the slope of the line. And so if we start labeling, so let's go 0, 90, minus 90, minus 180. And what we're going to end up here is the slope of the line starting over here at 0 is going to be is horizontal, so it's going to be 0. So our slope is going to be 0 phase shift along to here to our first pole 0, and then we're going to have a shift of, and we can calculate this, the phase is equal to the slope of the line in the magnitude times 90 degrees per 20 dB per decade. Okay, so in this case, our first case was 0, so our slope is going to be 0. Our second case, we've got a minus 20 dB per decade, and so times 90 divided by 20, which is going to result in a slope of minus 90, or I mean a phase of minus 90. So we're going to come down here to minus 90, and we're going to run across here at minus 90 till we get to our 50 out here. Okay, and then we're going to go back to a phase of 0, right? Because we've got a 0 slope, and so we go 0 slope through this portion, and then we're back to 90 again for the remainder of the plot. Okay. So our asymptotic Bode looks something like this, which is really ugly and not good. And we remember from last time, it doesn't transition like this. It actually transitions over a decade before and a decade afterwards. So we step back here, and 1 decade from our 2 and 1 decade forward, and what we'd end up with is a slope through here, and then we step back a decade from here, from our 50, and we end up through here, and forward from our 50 we'd end up out of here, so our line is going to go like this, and then step back a decade here, and forward a decade to here, and we end up looking like this. Alright, so now you have to use your imagination a little bit on this, and what our true Bode plot is going to be approximated by, let's see if I can do this, is going to be something like this. Okay, and that would be our phase plot for this Bode. Now, there's a couple of things that I want you to note as we move forward. Remember, our tools to reshape this, and that's ultimately what we want to do. We're going to apply a controller to this to reshape our Bode to make it a more beneficial shape for us. Now, one of the things I want you to note is that with our gain in here, with this gain, we can change the DC, right? And so we can raise or lower this plot with our gain. Okay? We also can change the shape of it by the addition of poles or zeros. Okay? Each pole causes it to drop down. Each zero causes it to rise up. And so we can change the shape of this with our tools, which are poles, zeros, and gains. Okay? So just keep that in mind as we move forward, because that's going to be a very important aspect of what we do in the future.